Hello everyone. In this video, we will be creating the virtual machine, a 64-bit virtual machine. So this is the continuation of the part one that we have created in the last video. The last video we have completely finished memory. We also have created a few functions like alloc and free, which allocates memory into our own virtual machine, and also we can free memory. So in this video, what we're going to do is actually talk about registers, the stack, and assembly, all of those things. So before that, I need to do a few corrections to this. So in this free function, you can see that it takes in the id and it can free it. But what if you given any id and it is already freed? So that is a big problem. And in languages like C with our current memory, this is also a big problem. Like when you free a null pointer, right? That thing is very common. So what we're going to do here is that we're going to say if we have to check whether the id actually is whether the id is like freed or not. So the way we can do this is actually check with the flagger, right? So let's say if self dot flagger, right, uh, dot get our id, and if this is false, right, we're going to throw an error, and then we're just going to, yeah, we're just going to throw an error. We're going to say rush vm um, is already freed, can cannot free a null pointer. Let's make null small. Yeah, so I'm going to give in the id over here. Okay, so uh, we can unwrap. All right, so that's amazing. So we're done with it. One more thing that I actually want to do is actually call this memlock and memfree, and I'm going to go back to my main and change all of this. So I'm gonna change alloc, right, to mem alloc for all of them. Amazing. And I'm going to colon this thing. I'm gonna call it memfree for all of them. So that's amazing. Now the reason why I changed them from alloc to memalloc and from free to memfree, the reason is because you can see that when we actually allocate something, we're taking in a binary value. But actually, if you think about it, actually, binary values, we won't really represent binary values in assembly, right? We need to convert those. What do you say? How do you say it? Like imagine you have like one, so you are representing it by like one in binary. But the problem is that in assembly you give the number one, or if you give a string like this string over here is not, you can't really allocate this thing, right? You have to convert this into a binary format, which you can do it. So we'll be having other functions which convert this, what do you say, binary into this. So memory is completely done. There was a few small fixes and now that's over. The next thing we're going to do is registers. Now, how? So now in registers we have things like RAX, so many of them. An example is an RAX register. So we are going to have a few registers over here. Like let's say pub registers. It's going to be a vec of string. So right, virtual machine. So what we're going to go here is we're going to go here, go registers. So this is a vector. We're going to have a few registers. So the first one is going to be R1, R2, something like this, right? We probably need more or less registers, but we're gonna have let's say 5 registers for now. And we can also have an accumulator register, right? It's a register where we do all the mathematical operations, so that it can be there. uh what's wrong? Oh, okay. Yeah, amazing. So registers in our virtual machine is going to be like we allocate something on in the memory. The registers are basically pointers that point to a specific cell ID. So that's how it's going to work. That's basically how it's going to work. So now, I mean to think about how do we implement this. So for example, first of all, we need a function that pushes into something or moves. So we'll say pub fn reg move, which stands for register move. You know, take in unmutable self, and when you take in the ID or not ID, the register of obviously. So register is going to be a string slice. Sorry. So first we need to check whether this is even a part of this. So um, how do we do that? Like, do we have any function for self dot registers dot uh, is it get returns a how do you do this? I think this is what we want. I want to see vector get rate. Um, returns a reference. What reference a reference to an element or subslice depending on the type. Okay, so how do you like let v is equal to 10 40 30. So yeah, okay, so this thing, oh, get is basically like okay, we it's not get. So we'll just um I'm going to create a register. Is reg available, just false. Then we're going to loop into them like for um what do you say, register in self dot registers if register is equal to reg, right? If it's equal to this, you're gonna set is reg avail to true. Yeah, okay, we need to make this mutable. We can clone this. Okay, all right. So yes, so what we're gonna do is if this thing, if not this thing, we're just going to panic. HVM unknown register. Yes, and we want one more thing. We have to allow non-snake case. Yes. Okay. So now what we're going to do is that we need to move, but we need to move what? So we need the value too, and the value can be also a string like that. Um. Okay. Yeah. So now it's very simple. What you do is just self dot. Why it's not? Yeah, memlock. Sorry, that's the problem. So for memlock, our value, right, and the ID. So our ID is actually what do you say? Um. We need to have one more thing, right? Wait 1 second. So let's just call this let mem ID cell ID. Let's call it this, right? We can't return that. Instead, we're gonna have what do you say? A control? No, not control. We need we need the exact data of what is there where. So registers is this. We need to have one more thing that where it says register values. No. Okay, so we can make this into an hash map. First thing we give it a hash map with the register and what else, the actual value. So no, the id, so id is string, right? So we're pointing to that, and here it's just hash map colon colon new. Actually, I need this. Gonna be hash map, quote unquote new, and we're going to right here. We are going to have the registers, right? Here we're going to have registers. Um, so yes, like this. Or should I say, yeah, this looks good. So what we're going to do now is self dot registers dot insert. What are you going to insert? The register name, right? Register name. Then we're going to insert not the value. We're going to insert the ID because we are going to make it like a pointer. Now we need this thing. So okay, nice. So regmove is complete. So what we can do is actually check whether regmove works. Uh, why is this shown cross? What does this mean? Is there maybe some deleted or something? Okay, let's see that later. So what I'm gonna do is I want to actually rust VM. So let's not have pointer 2, pointer 3. Let's not have this. Yeah, so this looks good. So what I'm going to do is rush VM dot allocate. I'm going to regmove. The register is going to be so we can have an enum of this register. So that's our next goal. But now I'm going to use R1 and I'm going to move the value of 1, 2, 3, 4, 5, 6, 7, 8. Yeah, once 8 times. So yes, so this is what I'm going to do, and we can check whether this thing works. You can see R1 points to 0001, which is our ID, and let's just in case, let's just check whether you can see that it has allocated over here. But you can see also that we have R1 register which points to this ID. So that looks amazing. So register move is done. Yeah. Yeah. So we have completely done drag move. So the next thing what we're gonna actually do is that I forgot in both memory and registers, we need to actually be able to get the value. So what is the use of allocating and freeing, but you can't really get the value? So we need memget. Pfn memget. We need to take in. We actually need self. Right? We don't need anything else. We also need the ID, which is the string, and we are going to give in back a string. So this is pretty simple. Get in the ID. No, it is not. We need to get this thing right. Yank. Yes. So GG and and yeah. So we got the column and row. Now what we need, yeah, one more thing is that we need to check whether thing is actually there, right? Um, Rush So here, if it's not there, right? So we're gonna panic. Um, so while panicking, what should we say? Rush VM. This what do you say? ID is not allocated. Cannot access um, memory location where we cannot access the memory location, which is no. That's good. Um, oh no. Yes, amazing. So we panic. Now we actually got to return this. So we got to return self dot memory, right? I think we can use dot get column dot unwrap. not get row, not unwrap. Uh, okay, so I think I can take this, put this here. Um, yeah, yeah, and this value we're going to return. This is how it's going to be. So we are returning the value now, memget. So let's just try how memget looks like. Um, let's print ln. We're going to print in point rush vm dot memget pointer one because that's the only pointer we have now. We can do cargo run. Now it should have, you can see that we get the value which is very amazing. So we are now able to get what do you say, the value as well. Now for register we also need to get some, we also need to get the value for a register, which is also important. So I'm going to am and let's make a new function. Regmove, we have regmove. Let's also have a function called regget that takes in self and it takes in the register name, just the register name. Yeah, and one more thing, we need to have an enum for registers, which I'll do after this. So, um, yeah, so it's basically we so we do self dot um what do you say, memget for what the ID. So for getting the ID, we do self dot registers, right? Dot get rec dot unwrap, and we're going to return this, and this will also be a string size with a lifetime of a. So okay. Wait, no, isn't it? Oh yeah, twist. Nice. So instead of, let's also print this as well as let's print um regget. Instead of pointer one, we're going to get what's the value in R1. So you can see that we also got this. So amazing. So are we done with registers? Not really. Actually, we are done with registers, right? So we're done with pointers. Basically, this is our pointers over here. Now the thing, we also have something called an accumulator. Oh yeah, the enums. Is it really necessary? We'll see about that later. Now we need now we actually like done with memory part. We're done with the this thing part. Now let's actually try allocating numbers, right? I mean, like we're just giving random numbers over here, like random binaries. Let's actually have a function that actually converts your this thing in your integers into what do you say, the respective binary part. And remember our machine is 8-bit, right? It's an 8-bit virtual machine. That also means that we can't support numbers higher than 129, I suppose. Yeah, 128. Yeah, we can't support number above 127. So so let's get started by actually being able to convert this. So we're gonna have, instead of memalock, we're gonna have just alloc and free. Over here, we're gonna have pub fn alloc. Then take in mode self, and it takes in basically the same thing. It actually takes in a value, right? And value is, it could be literally anything. So therefore, we're gonna take in t, right? And we also return, what do we return? A string. Now this is going to be simple. It's just going to be self dot memalock, right, and value like that. But we need to actually convert the value. So based on the t, we need to check on that. So we can't really wait. Can we like what can we do? Can we do something? So I need to see how do you actually allocate? How do you check? Um, Check what type of generic rust. Yeah, something like this. Um, I mean to check what the type is. Mm, not this. Yes. Hmm. We can I can actually use any type um as this Reddit user says rate any type, but all right. Let's see. Let's see. Let's see. I mean, I don't really like any. Right. But how do you check if value dot what value? Give me a check type something like that. Okay, any type rust. Yes. So we don't need any. So I think the previous Reddit user who said something right. I don't think that's necessary. So we can get back our generic. Uh, Reddit user. Yeah, this thing. So if type of T, if type ID colon off colon T like this as a function is equal to. Oh, okay. I like this. But no one really is gonna give a string when you use this. Wait, that's nice. What we do? Okay, not string, not string. Is I ate, right? Then we do this malloc. Sorry, memalloc. And the value. So we now need to convert integer to binary, right? I know how it works, but if there's some small little function, it would be nice. No, not a function like a standard function. No, I don't want to iterate all over this thing. Oh, this will work. Okay, I'm gonna go here and take in a number value. Oh no, like this, right? And we can return this. I'm just gonna do for now. Yes, type T binary. Wait, okay. The trade binary is not implemented. Okay, so um, okay, but like this, so it has to be static. I don't want it to live to other this thing. Want me to borrow this? Oh, it's this thing again. Oh, it is this thing. The thing that we had in the last thing, right? I don't want to do this. I really hope. Yes, I think this. Mm, you know what if I do it like this? So we can't really use format. Mm, so again, how do you convert uh, format this thing to yes sending and we saw yesterday. Okay, what about this thing? Open a cow. Okay. So what if we can like we had this. So what if I store it on the heap? Mm, that's amazing. So binary we just wanna say box colon colon into. Did I forget um how to get thing from box? Yeah, how to get our own money out of the box. Okay, just do that. Okay. How did I forget that? How did I forget the reference event? So what if I do this? So this doesn't work. How do we take any type? Right, we have to take any kind of type. Mm, listen, any type. Okay. So now this is a problem, right? So the problem is not here. The problem is allocating here. It is that we have to convert string into string slice with lifetime. Mm, no, not this. Two owned. How's it work? No, 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 not like that. Okay, two owned. Totally amazing. So I don't even need to do this. We need to panic, saying unknown, um, unknown value to allocate. I'm gonna go back to our main. Now instead of actually allocating stuff like this, what I want to do is I'm gonna do rush VM dot allocate value of 21, right? So number one, it's not really allocating. Okay, it's not allocating. I I didn't save it. Yeah, I didn't save it. I did allocate. Okay. Okay, so that is as I, yeah, you should allocate right now. Yeah, we allocated, but it is not really 8 bits, so we need to like get the padding. In JavaScript, we have this kind of way you can like pad stuff. Uh, Convert I8 to binary, right? Um, no, what I'm trying to say is that I want to get this to as an 8-bit thingy. That's what I'm doing. So when you do format B, right? When you do format B, format binary, right? Now what I'm trying to say is I want to pad it like, okay, if you give like this, it how do you pad? What do you say? How do you pad for binary? Yeah. Yes, exactly. Left. Okay, 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 okay. So we got that, but we want it to be zeros. Oh, we need to give in the thing. Oh yeah, you're supposed to put in zero like that 8 times. You see? Amazing, amazing, amazing. So we allocated 21 onto our amazing memory. Um, so now we are able to allocate stuff on the memory with our this thing. Now the second thing, now we're just supporting I8, right? So if you kind of get any other integers, we can't really support them. Now let me show you. Um, I mean, this you can't allocate them, right? The next thing I'm trying to do is going to be the most interesting part. I hope. Yeah, the next thing that we're going to do is going to be the most interesting part. Um, Register scamming mode on all of the stuff. Now we are going to do strings. Strings are the most interesting and more it's the most complex thing. So let's get started with strings. So let's get started with strings, the most exciting part. Okay. So um, so basically, again, I'm going to take this thing that we did before, right? So imagine this is memory. All right. I'm going to take one of these boxes. So now, what we want to do, yes. So what we want to do is store. Uh, yeah. What we want to do? No. Yeah. Store the value. Uh, Not really value. Store the string. Store the string. Hello. Now, how are you going to do this? So there are many methods, of course. So, but the method that we are going to do is actually like this, right? So first of all, we're going to leave a few spaces. Okay. over here like this. mm, yeah, something like this. So first of all, we're going to take the letter H, right? I want to move, yeah, bring to front. Okay, not really. So we're gonna keep it here. The first thing we're gonna do is actually get the length of the entire string. So how many letters are there in hello? H, one, two, three, four, five. Five letters. The first thing we're storing is five. The number five in binary, of course. Next thing we're going to store is um. So there's something called capacity. That means when you like extend the string, how much you can actually extend. So you gotta change the capacity again and again. So I don't think doing that is a good thing. I mean, it is a good thing, but I'm telling you, in the main, what I mean is that like having capacity, like something like that. Number one is very hard to track. Number two, I think I can give a better solution for that. So let's first focus on only the this thing. We have H, then we have E, then we have L, we have L again, and O. Now this doesn't end here. You have to do one more thing. That is given a null terminator, right, like this. So this shows that all of these things are like used over here. Okay, all of these things are actually used. And this is the last thing, and the last thing that we're going to do here, uh, one second, yeah, is actually give you actually have zero. So zero means this thing, right? Now what is this character mean over here is that for now this is just zero because it is what do you say, it's it's empty. So to actually say that this is empty, I'm going to one second. So here the zero is actually used. If you realize that the zero here is actually used, unlike the other ones. Just give me a moment. Oh, no. Here, this thing. Yeah, yeah. And the reason why we actually have a length here is to like know when the string, like the entire length of the string. And secondary, we also have a null terminator. Now what is this is free, right? Now imagine you want to convert the string hello to hello within this thing. How do you do that? Obviously one thing that we can do is actually take this thing. Is there a way to group? Okay, what's this group? Let's copy. So one way to do that is actually switch this, right? You can take this value, put this over here. Sorry, not yeah, you can take this value, like take this value like this. You can get this free value, right? Move the value over here and put the exclamation mark, right? And then move this. But the problem is that you're not really sure whether you have one of you're not really sure that the other one is free, right? It might have some data, very crucial important data. No one knows. So what I'm trying to say over here is that if the next character, right, this character over here, this one over here, this is zero because it's free now, but in an actual string this will also be useful. Let me tell it why. So reason why we have like two zeros over here, this is the null terminator. It shows that the string has ended. But the thing after this shows that the continuation of the string is going to be in some other memory location. Now it is zero because there's no other continuation. But imagine when you want to convert this into hello with this one, right? With what do you say, exclamation mark, right? If you want to do something like that, right? So we can extend the this a little bit. So imagine we have a few free ones here, right? We have a few free ones here. No, they're not really free. Reason being, but we'll just say they're free because uh, it- they'll be after it assured. But for in our situation here, let's just keep it as free. Now we're gonna have the exclamation mark over here, right? So what we actually do here is that right now what we do is actually change this value over here to this is column number three, right? 0303, something like this in binary, of course. So something like this will be there. So if you see, we'll get five. Okay, not five. This is six. It becomes six, right? So we go H. Okay, that's one. We go E. Okay, that's one. We go L. Then we go L. Then we go O. Then we find a null terminator. But once we get this null terminator, we're gonna see, oh, we have six letters. We have six. The length of the string is six, but there are only five characters over here. Where's the other one? Now we go to the next one over here, and it shows 0303. And now what 0303 is pointing to is to this location, or basically 0303 is the memory address, right? We can say it's the memory address of this, right? It's pointing to this. Um, right? How do you make this thicker? Oh yeah. So that's what this entire thing is. What do you say? Uh, it is a pointer to this, right? So it is basically nothing but a pointer. It points to this thing. So this is how we are actually going to do strings. So I hope. So this is how we're going to do strings, right? And I think this is a very good way of actually doing strings. So I think we can get started, right? Okay. So we're going to do it in a lock itself, right? So yeah. So what happens is that we're going to say else if type id of this right here, we go with string. If we somehow get a string, we are going to do a string allocation methods. So for that, I'm going to do something else called how do we say allocate string, which takes in mutable self, which takes in the string obviously, which is like this, and it's just going to allocate and return it back, right? It's going to return this. So I want to allow non-snake case. So yes, so what we're actually supposed to do, right? Yeah, we need to allocate strings. So the first thing that we're going to allocate is the length of the string. We need to take in the length, which is going to be use size. So so let's go here. We can just return, or we'll do that later, right? I'm gonna put to do over here, and also to do here. So yeah. So we put it to do here, right? And yeah, so I think we can get started by allocating stuff. First thing we need to allocate, right? um I'm going to do self dot allocate. I'm going to allocate the length, right? But actually we want to allocate it in like a close to each other. Like we have like 5, then we have h, something like that. We need to allocate close to each other. So we need something like allocate by group, right? We need to allocate into groups. So the reason why they do is that, imagine there was an empty space somewhere else, right? Imagine we have this empty space, so over here, like somewhere here. So over here, it can allocate 5 here and it can allocate h over here, which is not what we exactly want. um there will be empty spaces, but for strings I think it is better to like allocate them into groups. So we need another function that allocates into groups, right? Pub fn alloc group. Now it will take in, so it will basically reserve a few places and it can allocate them. um how do you do that? So like we have one, right? We allocate one. mm, Now that's interesting. That's kind of interesting. How are we gonna do that? So we want to get a completely new, what do you say, matrix of cells where we can allocate them. Problem is, how we're going to go with it. Like, we need to get a group of a few things. You can you can say how many bytes you want to allocate, right? So when you do memlock, you just allocate 1 byte, right? But if you want to allocate more than 1 byte, but they're together, right, with memlock, so we haven't implemented that. I think we can implement that. I think that's pretty interesting. So how do we where do we allocate in initialize memory value? No, npm no. Instead of memlock, we got to see how many things we got to allocate, right? Mm, so memlock, we're getting an ID. I mean, sorry, we have an ID. So we check if it's free, then we return that ID. We like put it in and we return the ID. But that's not how we're gonna do it. We're gonna have something called number of bytes that we're allocating, right? No, not by number of bits that we're allocating, because that's 1 bit. So how many bits you want to allocate, which is a U size, right? Um, and it's always one as a default. So that's a new thing. Now let's go to main. Mm, Memlock, yeah, we go here. We go and we have to provide the one over here. So we are giving only one, like that's the length. And we have to go here. We have to go to alloc, where we have to give in. Register always takes in one, right? But for allocation here, we need to take one because we're just allocating one I8, right? This number of bits. So when we check if self dot is free, this happens like if self dot is free and like this, right? We need to check, right? We say if, depending on the bytes, right? If the next few of them are um free, so this happens, we report and bits is equal to 1. Only if bits is equal to 1 it happens like this. But in our case, it's going to be how many bits? 1, 2, 3, 4, 5, 6, 7, 8 bits. A byte. So basically, the string hello is a byte for us. So we check if it's not 1, right? We don't really store it over here. What we do is actually, we do this, right? We actually do this. Mm, you get 5, but how do we say that? Okay, if the, so if bits is not equal to 1, right? And self dot memory memory of like this. And one more thing is that it should be all on the same row. Okay, so I don't think this is a good way to do it, because 5, there is no way that it actually goes. The next one should be h. It can actually 5, uh, but there's no other way. I think that's the only other way. Right, we go row as u size plus 1 if it's free. Right, so we need to also check. Okay, this is complex. The first thing that we check is that if it's free. Okay, if it's we found that it's free, but that only happens. So this goes like if bits is double equal to 1. Yeah, else if. So it no. So basically it's like this, right? And we have if bits is equal to 1, only one bit, nothing else, like that, right? So else if it's not, it's not, um we say else, else, right, bits is more than one. We take this, right? So from memory we take this. So from memory, yeah, this is the current id, but what we want to do is that we need to check if this one and this one dot, it's not id, yeah, dot id. No, not really. We need to get the next row, right? If this row, like this, right, if this is free, then amazing. So we basically do for um new row in row 2 bits, row 2 bits, like this, right? I just want to print ln, I just want to so we're gonna put to do over here. I want to print n row. mm, so we don't really get anything because we haven't really allocated anything in the first place. So here, instead of self dot alloc like this, we're gonna do self dot memalloc directly. We're gonna put in the value as val and bits as len. And here, what we're gonna do is that we're not really gonna put this, right. We're gonna say we're gonna return this, right. Obviously, it just returns one, so we're not gonna really return anything. It's gonna be like this. Um. mm, we just call all string. Value is gonna be hello. Length is gonna be 6, like that, like that, right. Huh, I don't think anything even worked. Okay, yeah, because we never call the function. If we need to go to main, we need to allocate vm dot allocate the value as this, hello. Required by a bond, what does that mean? That's a big problem. But we can actually fix that, right? We just go to VM. Um, we can actually go here and we can actually say impel binary for string like that. Is std colon colon, how do you say std types? No, infiltrate infiltrate for string, and then our book said something. No docs. This thing, right? So we're always going to return an error. We're going to return result of nothing. Oh yeah, we're going to return okay. Uh, we're getting more and more problems with all of this, right? So with our alloc, right? I think let's remove our traits and instead go for type, which is string, and that goes that if type is equal to int 8, we do this. Else if, oh yeah, we don't have it, right? It's like um value is of type any, right? What happened? Oh yeah. So yeah. Else what happened? So I think we can just say data type like that. If it's mentioned, so oh yeah, else if. Now impel any, okay. How do we do this? So we go back to our previous thing, to our anything, right? Type ID, sorry. Rust guy. No, where was Rust guy? Now, how did we do that before? We didn't use any. We used this type ID. Just type ID directly. Hmm. Okay, we can. Can we do val as? Can we do it like this? And can we go val as usize? If you put unsafe, does this thing work? No. Mm, I mean, we could do that. Impel binary for any. Right, we could do that thing that we did before. Any. We did we find the. Is it from type ID? No, it's for any rust. Yeah. No. Oh no, where is that thing? We just had that pub and something something. Yeah, this traits. No, trait to. What I'm trying to say is that the anything that we had before, like um any, okay, any, we want the traits of any. Like sorry, not the traits, the impulse of any, right? Impel any is that. Yeah, impel any for this thing. Source. Yeah, it must have this thing. Right? Format. FNFMT. Yeah, that method. Yeah, we got that. No mind. And we're just going to return okay, like that. Mm, Oh my god, I solved it. So work now. I mean, it won't really work. We need to get our real error. I need to provide int 8. I provide string. And we get the same error. Okay, we need to provide type of t, right? Type of t is what is t? I8. We don't need generics. We need. Okay. So yeah. What if I? So yeah. Result of. Mm, yeah. What? String. So how do we? Yes. No, yeah, something like this. No, um, impl for string, and then you want me to do this thing. How do you do it then? 1 second. So yeah, okay. So this thing doesn't work. So I just got an idea. Why can't we just have many alloc functions, right? We could just say alloc, interlock, right? And it still takes in t, right? It still takes in t. No, it takes in t and it takes in the this type, right? Data, not really, bits, and that is a use size, and value is t again, t which yeah, basically like this, but we don't have, yeah, if bits equal to 8, something like this, and we go here and we can't really do this, but instead we go here and go interlock, and then we go here and go 8. Now everything should work properly, and we should get the value 21 allocated properly. Yeah, it is allocating. Now I'm going to exit. I'm actually going to go back to my VM, and so now everything is clean now. Now let's go with string allocating. So um string allocating, very important. And here is cannot allocate integer of bits, this thing. Okay, yeah. Okay, let's go. Let's go stirlock. That's a nice name. So we need a value again, which is, yeah, no, not really. Let's take in a string. This also returns a string, right? So now that looks amazing actually. So the first thing we need to do is that we need a length of this, right? So let's take the length is equal to val dot length, and we can put to do just in case. Now what we're gonna do is go back to our main, right? We're gonna go rush vm dot stir allocate. We're gonna go hello to string. Yeah, not yet implemented, but you didn't print anything. Oh yeah, because this, right? Now what we do is we actually allocate stuff, right? We're gonna go self dot memalloc. Value is going to be val. Bits is going to be 6 actually. We actually got to get that, right? But never mind. So we can go to string. Then no need of actually doing it. It's really having it as a string slice is even more efficient anyways. Yeah, we are getting more than one, right? Please. We got 0, 1, 2, 3, 4, 5. Now what does this mean? What does this mean? We're printing end row, right? Row till bit. So yeah. So basically, row row is zero then. Huh? Oh yeah, right. No, didn't quite understand. I want to just print row. We're in the first thing. So what we check right now is that yeah, instead of doing this, what we do is that we go end row. That's right. Now what we check is that we get the ID, right? We gotta get the ID. Um, wait, this thing. We're gonna go let val for now. Doesn't really make sense. Or ID, yeah, ID is a code word. ID. Now what we do is that we check. What do we check? Um, Safra flagger dot get for our ID. We're gonna get that. Maya dot unwrap. That's rushed. Cloning what? This entire thing. All right. I know how that works. True, 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 true. Now what does true mean? I have no idea. True means there's something is allocated there, right? If something is allocated, then it becomes set to true. No, it's not call. It is end row. It's not row. It's end row. But why do we have so many truths? That's my question. It's a true, true, true. That's the first three are allocated, and the next three are not. And that's what we need. That's exactly what we need. Now this looks amazing because if it's true, we're just gonna skip. We don't care. But if that is false, right? Um, now once we get false in that thing, right? So we say what we say. If we say like if this is equal to false, so we start a flag here, right? We start a new flag here. So we're gonna flag is equal to um a current end row. It's actually end row by column. Sorry, column by end row like that. Now what we're gonna do is gonna do for we're gonna go to the next column, all right? We're gonna go for um no for end row now. I mean yeah for new row now we go how do you say mm, we go to the next column. So column is there. Okay, all right, all right, all right. Now what we do is we get this right, but we do println. It's the same thing, right? Now we got all false. What we do is that how many falses do we get? And we have a flag that says from here. So from here we need to check the other thing. So we go like for x in uh call no for x in row till bits as I 8. Same thing again. Not really row, it is n row. From n row. Right, I wanna print x 345. Um, not really. I wanna print both of these. So nothing's allocated in 3, 4, and 5. Right. But my next question is why is 4, 5, and 5 coming again? What row is it? I wanna see flag also. So we get 0 row, 0, 0, 0. We get 0, 4. We go 0, 5. I don't understand. Wait, 0. Wait, the flag. Our original flag is 0, 3. Okay, so once we got three things here, our flag is actually 0, right? And it's mutable, first of all. So once we get an empty thing, okay, we check whether the next things are empty. We check then if the next one is empty, right? If um the same thing here, instead of ID, we go like this with n row plus 1. We go like that. We go like this. Then we go like that. So it's basically new ID. I think that is a problem here. The problem is that we need an NID, which is the same thing, but it's n row plus 1, and we get like that, right? Semicolon. Now we check if this thing is false. That means the next one is false. So we do flag is equal to flag plus 1. Okay. Now what we do is we go for x in n row, not really n row. Is it n row? N row plus 1. N row plus 1 to this entire thing minus 2 because minus 2 minus 1 minus 2. I want to do that. I want to exit. I want to do that. Um, we get three false again. Did I save that? False, false, false. I want to see flag too. 0, 0, 0. It's not incrementing. Flag is mutable. Okay. Has to be 1 then. Yes. So we got three things here. Now we go for x in this thing. N row plus 1. So what is n row then? N row is 3, but n row plus 1 is 4. So this should be 2. No. Because what is NID? Our new ID is 004. So 003 was empty, isn't it? Did we allocate anything in 003? I want to see self too. See, 003 is empty yet. That's right. So in ID, so 003 is really empty. Sorry, what am I doing? Here. 003 is completely empty. So we go 004. So what we do is that flag, whatever that flag is, let's say let empty, um, let empty cells, yeah, empty cells is equal to our ID. Then we push in empty cells dot push NID. So we need to make this mutable. Okay, this is a vector. It's a vector of vec like this. So we are borrowing it here. Our flag is not useful anymore. So what I want to see is empty cells. I want to see empty cells like that. So there's a problem. Okay, ID. Consider, okay, type annotation. Um, so ID type annotation. Okay, so I'll try cloning it. Okay, ask me to borrow again. So if I borrow by cloning it, that doesn't work still. So I don't have to clone it for unnecessary memory. Uh, um. Oh, okay. So ID is string, not string slice. So we don't need the borrow anyway. Okay. Fine. And then I borrow here. Fine. Then you tell me you can't borrow, so I'm gonna clone this thing here. Now what's the problem? So there's no problem. Okay. You can see we got our empty strings, empty cells, that is 003, 004, which is correct. Completely correct. I think I think this should be outside. Going back on new. Then we so here we go empty cells dot push what id. So we got 003, 004, 005, 00. Okay, one, two. We got 005 twice. Got 003, got 004. Right, right. Um, see, we push an ID. Okay. What we do is that we gotta check, right, if empty cells get empty cells dot length, it dot unwrap. If that is the same as ID, if it's not the same as ID, we do this. We're getting the last element. Dereference this, right? Yes. Hmm. So you're telling me empty cells? Oh yeah, empty cells doesn't have anything. The first. Oh yeah, right. So it's not like this. So match empty cells. So we go none. We do this. If it's none, we do this, right? But if it's sum um of cells, and we go last empty cell, right? Last cell. We go if last cell is equal to id dot clone. is equal to the id. If it's not equal to the id, then we do this. Interesting. Very interesting. So we got 030, we got 03, 04, 05, 06 is exactly what we need. But this is on the first row. The first row we got four of them. Now what we do is that once, now what is this? I'm not really sure what happened there. Yeah, so now we got this, right? Now what we do is that now we now we go now we come empty sources over here. Okay, so we go like this, right? Now this end of this for loop is here, I believe. Okay, it's here. Now telling me we do the same thing again if the columns. So it's like this. Now what we do is that we check if if end row if empty cells dot length is equal to bits. If it's not equal to, yeah, if it's not equal to those bits, what we do is we do the same thing again. All right, we go here and we do the same thing again once more, but instead of call we increase the call over here like that. Now let's try. You can see we got 03, 04, 05, 06. We need to clear empty cells, right? So we say empty cells is equal to where colon, we just clear them. Now we go, we do cargo run. So we got one cell, two cells, three cells, four, five, six. They've been repeating. They're repeated. Wait, what? Why is the 003 coming here and 004 coming here? 005, why are they coming? Except for that 03, we got three here. Got four, we got five. We got, the thing is working, but we somehow getting 003 again for some reason. I am not quite sure why. See, now we don't need this thing, right? This is confusing. We don't need that. We can exit. If you do cargo run, first we got 010, that's correct. Then we got 0101, then we got 0102, but somehow the column, oh yes, the column changes. Wait, now let me just exit off the terminal because can't understand anything over here. Oh yeah, so we got the for loop. So we got the for loop again. Oh yeah, here. So guys, I think it works. It works. Now we are able to get these things. Now what we do is just come here, come over here, and what we do is we print ln empty cells. So you can see that we got all our empty cells. That is just so good. That is so good, to be honest. Now, as we got all our six empty cells, we're gonna take in all of them, and then we're going to allocate. Now, our value here is just one of this, right? But this should be like an array of this. It should be a vector of these things, all right? And when we go for the first thing, our value, right? Wait, so my recording thing cut off after 30 minutes. So yeah, so whatever I was saying. So yeah, we take value over here. So where we okay here value, we take value of 0. All right. So nothing else is wrong. Everything is here. We still have to have a few errors. Yeah, exactly. So what we do is over here we go vec like that. Where's the next error here? Vec of that. Let me save that one so that error goes. Then vec here also one more time. No, not really. Vec of that, then not value, not no no no. We're gonna take length first. So yeah, we're gonna mm, okay. We're just gonna take value. So first we should be able to allocate all those stuff in all those different segments. The first thing we need to do is that we need to check if value dot length is equal to bits. If it's not equal to bits, we're gonna panic first of all. We're gonna panic saying rush VM um cannot allocate in cannot allocate bits in this much requested bits. So value dot len and bits, right? So that is a problem here. So we should get that error actually. Yeah, this should be an error. Oh, okay, there is an error, but there is a syntax error. Amazing. Exactly, cannot allocate one bit. So we can say cannot allocate one bits in requested bits. Yes, that looks clean. Yeah. Now it's time to actually allocate. Now it's actually time to split the string and actually do the stuff. In std we need to get let characters is equal to val dot chars dot collect. Right. So this should be a vec of char, right? Right. A second thing that we given, yeah. So we can say let params or args, which is a vector of string like this, right, is equal to vec colon new, and we actually given args here. Then we go, first of all we're gonna go args dot push length, it should be mutable. Then we go for character in characters, we're gonna args dot push character dot as dot to string dot as string, like that. Yes, and u size we're going to convert this into this thing, so we're going to say format. Oh, can't do format. U size to string. Yeah, exactly. Wait, I can just go to string, a string. That's not missing. Oh my god, the error that I hate the most. Temporary values feed at the end of the statement. This thing. So this asks for FNAM. So split this into many extras. Yeah, exactly. The characters dot skip one. That's not a problem. So here is the main problem. Fine, then how do I say that you have to leave? So there's no way to say as str. It's only the way to say to string. Again, string to str with lifetime. Again, how do I convert a string to a string s- slice with a lifetime? Um, borrow with lifetime. How do I borrow with a lifetime? Hmm. We need to be able to borrow with a lifetime. Here it is shown on the heap. We are converting it to a string, and a string has a lifetime of static. We need to convert the lifetime static into lifetime A, and I don't think we can do that. Let's see what the compiler says. Okay, that is correct. Now, if I borrow this, it shows this error. So let me do cargo run, and pay the same error again, right? Um, I mentioned that len is borrowed for a like that. The borrowed value does not live long enough, right? I have a question about that. I have a question. Yeah. Um, so what if I do this? Okay, then borrow it for a. Because if I go here, right? If I go here like this doesn't give an error. But here it says argument request length. This borrow for this. So let's see what compiler says. It does not live long enough. Or if I go ask mutable string, same thing. So again, use size to string slice rust. Such a simple thing. Or we could just get the length from the user. But that's not good, but I don't care. Hello has like length is 5. HELLO, yeah. So when we memlock, we so args we push in the character, then we also have to push a null character also. So 1 2 3, yeah, exactly. And then we push one more thing, which is this, right? Now we go back to our this thing. So now if I exit and if I go and if I go cargo run, can I allocate 8 bytes? There 8 bytes? Huh? Fine, then I want you to print me value to 5 HELL. Okay, they are probably fine. Then let's allocate 8 bytes then. No worries. So you can't really say it's 8 bytes, right? So you say you go with as cars dot len, which is 5 plus 3, like that. Not characters. So you can see we get this, right? Now we can allocate 5 into this, h into this, something like that. So that's what the next thing we're gonna do is we're gonna do that. So we're gonna go back to here. We're gonna so first, so we're gonna go for I in. Do we have I declared somewhere? No, probably not. Do we have I? No, we don't have I. Okay. So for I in our empty cells, we go we allocate the first. So we allocate self dot memory of. Now the question is which column is it? Um, Good question, right? Which column is it? I don't know. We can't really say. So to get the column, we're gonna do this. So we're gonna go. So we need to column and row like this. Like I'm gonna go for column like that and row. No, should be instead of column, it should be like um empty cell column and empty cell row, empty cell row, like that. And I'm not really sure whether the loop that we said before +1. I'm not really sure that why. We probably need a flag that goes with the extra columns. I have no idea. So we get the empty cell column from. Now what we do is we actually allocate. So self dot memory of empty cell column. And that's a string. That's a problem again. So we need to do the same thing again here. In this way, yeah, this exact method. Here we need to go and go paste. We need to go this. So instead of column, we're gonna go paste this in, and we're gonna yank this, and we're going to paste this thing like that. And we instead of saying that's 0, that is going to be our value of I. Oh yeah, right. It's for. It's not really I. It's for I in range of empty substrat length. So they are 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, what? So there's 1 to this rate. Should be 1 till that. So I think let me just try cargo run. So index is the miss is 0. So self-run memory. Yeah, I actually want to see what is value of I. So we're going to println. Setting this up. Okay, we have just 10 moments for this period, for this part of the video. Okay, so guys, get 5. Yeah, all of them are working. Now all that we need is this first thing. So we say start pointer, multiple start pointer, which is a string start pointer id, and then the first thing that we get, the first id that we get, where is id coming from? Is it id? Format id? No, it's not id. It's I. No. Um, what's the id? It is empty cells of I. The start pointer id will be, because start pointer id is going to be empty cells of I. And I think the best thing that we can go is go here. Sure, I can clone it now. And there's one more thing that's just very irritating. Yeah, and we have to return start pointer id. With this, I hope. So it didn't allocate. You can see still 0. Did the value actually change? I want to print this then. I don't think this is necessary. So I'm gonna go exit this. I'm gonna go. Let's go. Cargo run. So you can see that we get uh yeah, we printed before allocating, right? Good. So 0 0, not that. Wait, why do we have this? Okay, I'm not really sure why we have. Why is it allocating at where's the ID? Where's the ID 0? Where's the ID 0? Isn't it supposed to be empty cells of I? So I think this the problem is with, I want to see empty cell call and empty cell row. That's the problem. The problem is that so we got 0 1 0 0. Okay, that's working. So why can't it actually split? Oh yeah, over here. That's the problem. Nice, nice work. Now let's hope our amazing string is allocated. I don't think so, but let's see. Wait, it is 5 H E L L O with this and this. Oh my god, let's go. It allocated. That's amazing. But there's one thing that we haven't done, that is we need to set a flagger. Flagger dot insert our empty cells of I to true. So now if we run it, now if I go, if I close my terminal, if I run it, you can see we got a lot of truths here, right? See, we have a lot of truths here. And when you go back to our this thing, you can see all of this are plain, right? But here we got our 5 HELLO and our two these things, and here that's amazing. So yeah, in this video we have completed with registers. I'm going to remove this formatter for this thing. Yeah, so in this video we completed with registers. We are done with, we modified a memory, we were able to get the value of registers and the value of memory, and we'll also be able to allocate integers into memory, and the most interesting part, we'll be able to allocate strings into memory. So yeah, thank you so much for watching the video. Have a nice day.